Hello and good morning everyone, and thank you for joining our webinar with Kenna Security today. That's going to be focusing on using data science to patch fewer vulnerabilities. So we're delighted to be joined by Ed Bellis, who's the CTO at Kenna Security, and also Andy Parks from NSTAR Group. On the call, he'll be discussing why NSTAR deployed the Kenna Security platform.
Okay, thank you very much, and good morning, everyone. So today what we're going to be chatting about is I'm going to walk you through a number of the different models that we ended up building here at Kenna, as well as analyzing in terms of remediation performance and how well did the various remediation strategies perform when looking at actual high-risk vulnerabilities. And I'll talk about a little bit about what I mean about high risk in a moment, and then kind of show you the differences between those models, the whys of what ends up being important in terms of choosing a remediation strategy for your vulnerabilities, and then a little bit about how we can actually help with that within Kenna, and then we'll pass that on to Andy, where he'll walk you through some real world examples as well. So first, let's set the stage a little bit with the actual problem that we're trying to solve here. When you think about the volume problem, this is just one way of looking at it. In fact, it's actually pretty minor, this graph, when you compare it to the actual real world problems around vulnerability management. But this is a graph of all of the published vulnerabilities, or CVEs, from the National Vulnerability Database over time. And as you can see, it definitely starts to spike, certainly in the last several years. But there's some caveats here, right? It doesn't mean that we as an industry or as a software industry are more or less vulnerable. Actually, what this is meaning is that the process of publishing a CVE is becoming easier, and more companies or CANs are able to do this. So we're actually we're getting more and more visibility into those vulnerabilities. But as part of that, I'll then have a single instance of that CVE across many assets or systems within my own environment, which results in one CVE actually may exist within my environment tens of thousands, hundreds of thousands, even 1 million times, depending on how many assets that I have. So it's really a multiplication problem here when you're looking at it. So where you might have a subset of these CVEs, you're going to have them spread across your environment, across many different assets. So being able to get a handle on the volume of vulnerabilities and really applying any sort of remediation effort that's going to address every single vulnerability within your environment becomes unrealistic very quickly. But there's some good news out there, and one of the things that I'd love for you to take away here is, while there may be a lot of vulnerabilities out there, I don't believe that you have to fix every one of them. In fact, I would argue for some of the vulnerabilities that are out there, you're much better spent using your resources doing other things to reduce risk. However, there are some very serious vulnerabilities or very risky vulnerabilities within your environment that absolutely need to be taken care of. And what we took here was, if we took all of the published CVEs across the National Vulnerability Database, and we looked at them and said, okay, so of these, how many of them have some sort of weaponized exploit associated with them? And to give you some background there, we're scouring a number of different sources there, both public, private, as well as even some of our own sources as well, to basically say, do you have a weaponized exploit for this vulnerability? Does code exist that could exploit this vulnerability? And then taking it a step further and saying, have we actually seen this vulnerability being exploited in the wild? And some of them we've seen once or twice, some of them we've seen many, many millions of times being exploited in the wild. But that really narrows down the focus. As you can see here, now we're dropping down from 120, 130,000 different CVEs to roughly just over 20% of them have some sort of exploit associated with them. And really only about 2% of those are we actually seeing successful exploitation events in the wild for. So in order to measure your remediation strategy, there's really kind of two big key metrics that you want to look at. And one of them is coverage. And let me explain coverage to you. So imagine, if you will, there are 100 high-risk vulnerabilities. We have 100 vulnerabilities that we know have some sort of exploitation code or event associated with them. And I go out and I fix 85 of those 100. That means my coverage there is 85%, or I remediated 85% of the high-risk vulnerabilities within my environment. And the other key metric here is efficiency, which is really kind of the counterbalance, which is, you know, when I go out and I deploy resources to go out and fix a vulnerability, was it valuable? Did I actually reduce some risk? Or was there some wasted effort in there? So take that same analogy, but let's say I go out and fix 100 vulnerabilities. How many of those vulnerabilities actually were high risk? How many of them had exploitation code? How many of them had exploitation events in the wild? So if I fixed, you know, 100 vulnerabilities and let's say 50 of them were associated with high risk, then I would have an efficiency metric of 50% there. So in order to really start to understand what it is that we have to deal with, we also got to think about speed, or what is the timeline to an exploitation for these given vulnerabilities. So this particular graph that you're looking at here is taking the published date of a given CVE vulnerability and then examining, for those that we did see weaponized exploit published for them, either public or private, how quickly did that come? Now remember, you're talking about only about 20% of all vulns ever have any sort of exploit associated with them. But of those 20% then, how quickly did those come out? And as you can see, it really clusters within around several weeks of the actual CVE published date. So if a CVE gets published, we can expect, if an exploit's going to come out at all, it's likely to come out, say, in the next 6 to 8 weeks of that published date. But you can see it does span. There are very small lines all the way across. So there are some that are well over a year after a CVE gets published, and in some cases, anything to the left there is actually really a 0 day, in the sense that the exploit gets published before the CVE gets published. So we then broke it down by a few different years to just kind of see what it was that we were dealing with there. So we looked at all of 2015, all of 2016, all of 2017, broke those down by percentage. As you can see, it's roughly the same, but what gets a little bit more interesting, because if I go back here, you can see I didn't have much time, but if I look at the instead of the published date, the CVE assigned date, that gives me a bit more time. So now we're dealing with, because a CVE gets assigned an identifier typically before it gets published. Like a vendor will come out, may say Microsoft says, hey, we know about this vulnerability. We get a CVE assigned to us via MITRE in the process. And then maybe a week later or something like that, we'll actually publish that CVE. So that gives you a little bit more time. Now that's not very interesting to a practitioner when all I have is that assigned date. But as you can see, you'll be able to see when we look at these models, there is some important differences that give us a little bit of data about that vulnerability as it gets assigned, which gives us a little bit more time to do some predictive analysis about whether we think an exploit is going to come out. So that's weaponized exploit, but what about actually seeing these exploits being successfully used in the wild? So again, now we're talking about a subset that's down to, roughly about 2 to maybe 3% of all of the vulnerabilities that are published out there. As you can see, once that exploit gets published, meaning once the weaponized code comes out, it's a steady stream. But this is the first time we see it, but it could be 3 years down the line is the first time we see it. But once it happens, it tends to happen a lot, and it tends to happen for a long period of time. In fact, we're still seeing anything that you see that is out in the news. Obviously, the Bluekeep is probably one of the more recent things, but we still see things for the Struts vulnerability that's constantly spraying across the internet. There's a lot of things that are going on there that you just see for a long period of time in terms of exploitations in the wild. So let's take a look at some of those various remediation strategies, and we'll compare and contrast them to each other using both the coverage and efficiency method metrics that I talked about earlier. So the first strategy that we often see people use prior to coming to Kenna is actually saying, hey, you know what, we're going to focus on our key vendors. So in fact, we often see if anybody's good about remediating vulnerabilities, they tend to do pretty well with Microsoft. They have some sort of cadence around Patch Tuesday, things like that. They might do well with some auto updating vulnerabilities, Google and Google Chrome and some things like that. They tend to not do well as you would expect on some of the Oracle things, specifically since Oracle owns a lot of different things, including Java, where vulnerabilities become a little bit more difficult. But you'll see often people are focused on some specific vendors, especially ones where they've kind of automated the process. And they say, okay, we're going to go out and we're going to fix, you know, all the Microsoft vulnerabilities. We're going to go out and fix all the Google, all the Adobe vulnerabilities, something like that. So we took those strategies and we said, what if we took the top 5 vendors or the top 10 vendors or even the top 20 vendors and we fixed everything that they published? What would our efficiency and coverage be if we took those as a strategy? And as you can see, even if we took the top 20 vendors, which I rarely see, but let's say you focused on the top 20 vendors that are out there in terms of number of published vulnerabilities, your coverage obviously is going to get better, but you still fixed roughly about 22% of the high-risk vulnerabilities. In other words, you've missed almost 80% of the high-risk vulnerabilities that you may have in your environment. And your efficiency is quite low in the fact that of those vulnerabilities that you did fix, only about 12% of them were high risk, or 88% of them were not high risk. So obviously this did not perform terribly well for either metric, either coverage or efficiency across the board. So let's take the next look, which is at CVSS. This is by far, prior to coming to Kenna, when we're talking to companies out there, probably the #1 strategy that we see in existence today, which is to take a look at the common vulnerability scoring system. What is the score? Rank it. In fact, some compliance measures have been kind of baked around CVSS historically. And let's say I go out and fix every particular, I've created an SLA or some sort of service level agreement around any vulnerability that's got a certain CVSS base score. I'm going to go out and fix in X amount of time. As you can see here, what this is distribution across all of the CVEs. Ironically enough, when you actually look at the CVSS calculator and how things are calculated for a score for their base score, it's almost, as you can see, impossible to get a CVSS 8 for some reason. The vast majority of them are 7s, and then there's, you know, they cluster right over there on the right. In fact, if you look at CVSS, there almost is no such thing as a low risk vulnerability, right? There's almost nothing in the ways of 1s, 2s, and 3s that are out there, and that'll become apparent here when we analyze this strategy. So we took the same sort of approach and said, all right, so what if I just fixed CVSS 10? Okay, what if I fixed 9 and above, 8 and above, 7 and above, 6 and above, and all the way down to 5 and above? Obviously, as I get lower in the score, I'm adding more and more vulnerabilities to remediate, so my coverage is getting better and better because I'm just fixing a lot more stuff. In fact, if I told you, you know, go out there and fix everything that's a CVSS 5 and above, you're actually fixing almost all the vulnerabilities in your environment. As you saw, there was a bit of vulnerabilities that were scored a 4, and almost nothing below that, right? So you're fixing almost everything in the strategy of fixing CVSS 5 and above. So your coverage becomes better as you fix it more and more of the vulnerabilities, because you are fixing more and more high-risk vulnerabilities included in that. But your efficiency is not getting any better, because you're just creating this big swath of remediation effort out there. So you're fixing a ton of stuff. Many of it is low risk, some of it is high risk, and you're just fixing more and more stuff. So this approach, as you get further down the scale on the left there, it's just taking a sheer Herculean effort in terms of actually going out and fixing everything that's a CVSS 5 and above. So then we looked at reference lists. So this one we see certainly less than CVSS. I'd say we even see this a little less than the vendor approach. But some folks are out there actually taking a look at and subscribing to various email reference lists around vulnerabilities that are being published. So we took all of the most popular reference lists that are out there and said, what if every time a vulnerability is published in any of these reference lists, I go out and fix this? What does that look like just in terms of my coverage and efficiency for remediation strategies? And as you might expect, actually, the one thing I did discover, which was a little bit of a surprise to me, is the bid list, as you can see there on the bottom. Again, none of them approach a great efficiency, meaning there's a lot of vulnerabilities that are not high risk that are in there. But the bid list actually contains about 74% of all of the high risk vulnerabilities. So that was an interesting finding for me, at least. But it's not necessarily a great way to throw together a strategy around remediation of your vulnerabilities. So let's create a model where we actually go out and instead of an after the fact analysis of the data where I'm sitting there and just saying, okay, let's fix this, let's fix this, let's fix this, and hope whether or not there's going to be an exploit, it is going to be end up being a high risk vulnerability or not. I actually make a prediction at time of publication as to whether or not there is going to be a weaponization for this particular vulnerability. And we ended up building several models. We built one that was based purely on the CVSS base vectors and computed the score. We built another one which was on products. So we used the CPE data on the vulnerability. So CPE being the common platform enumeration, which kind of is a fingerprint that describes the vendor, the software product, and the version of that particular piece of software. We did another one on the reference list. We looked at the strategy there. We built another one which we called words, which is really just text analysis, where we scraped all of the description. We looked at all of the references that are in the National Vulnerability Database, the reference links, where other sites were talking about this particular vulnerability. And we scraped all of the text from those sites as well. And then we extracted keywords and phrases in order to kind of put together a meta description, if you will, of this vulnerability, and created a model around that. And then finally, we created what we call this everything model, which is incorporating all of the 4 models and combining some of their benefits together to kind of see how we would do there. And as you can see, this is kind of extracting it out. So to explain this chart just a bit, on the left is your efficiency. And again, as a reminder to everyone, efficiency is if I go out and fix 100 vulnerabilities, how many of those were actually of high risk, right? Versus how many were not, and I was kind of had some wasted effort in terms of my remediation process or resources. And then coverage is that bottom axis, and that is really of the 100 high risk vulnerabilities, how many did I go out and fix? And when we talk to many customers, they might actually skew towards or lean towards, hey, I want to do better in coverage than I do about efficiency because I have a lot of resources, and I want to drive that risk down as low as I can. There might be other customers that want to lean a little bit more towards efficiency because they don't have many resources and they want to make sure when they go out and deploy resources that they're fixing the right things. And then there's others that are kind of want to have that balance. In other words, you know, hey, I'm somewhere in the middle. Ideally, I would love to have high coverage and efficiency, as everybody would. But if I had to choose, I want to balance those out. And that balanced approach means that if you're looking at this graph, up and to the right, that middle of any of these lines, you want that to be as far to the top and to the right as you could possibly make it. Obviously, the everything model performed better than everything. Words did decent. Reference list was not actually bad when it came to efficiency, although the coverage tended to drop a bit. And as you can see, both CVSS and products did not do terribly well on their own. But this is kind of breaking that down again by their coverage and efficiency. And we took that everything prediction model and we said, okay, if I wanted to skew more towards highly efficient but still get some coverage, what would that look like? And it was roughly about 80%, 30% in terms of a highly efficient model. If I did the balanced model, I could get over 61% of both. And then if I chose coverage, I could still, you know, skew to roughly 82% of coverage while still getting almost 48% efficient. So what I want to do is when I'm skewing towards coverage, I don't want efficiency to suffer as much. So that's why we're trying to balance these out together, because you can see one kind of as a driving force against each other. And as they always say, there's no such thing as a perfect model, but some of these are useful. So let's take a broader step, and what we did is we looked again at that model, and that's the top kind of light red line that you see there, and we charted out where it will fit from a balanced approach, a broad coverage, a highly efficient model. But then we've also plotted here every other strategy that we talked about or analyzed, and where that fit in terms of both coverage and efficiency. As you can see, I don't know if you can see in my chart here, there's a dotted line at the bottom. That's interesting in the fact that that represents random. In other words, if I just picked a CVE vulnerability out of the hat and chose that to go and remediate, you can see there are some strategies in there that performed worse than random, that I would have been better off just randomly picking a vulnerability and fixing it. I would have had a better chance at fixing a high risk vulnerability and not wasting my effort as choosing some of these other strategies. But some of them that finished a little above random, including many of the CVSS remediation strategies. But all the model, the prediction model, really outperformed all of these. So what does that really mean in terms of Kenna? So that the model is one of many things that we're actually doing. So when you think about what the model does, we're using that as a way to predict a weaponization of a vulnerability prior to that vulnerability or prior to that actually happening or occurring. Obviously, that's the first step as we analyze. First, we see weaponization of that vulnerability. Then we actually see successful exploitations in the wild for that vulnerability. That's great for the ones that don't yet have any sort of exploit associated with them, because then I can get proactive about that and I can go out and pick and choose and fix vulnerabilities that I believe are going to be high risk in the future. In other words, get ahead of those attackers. However, we also have the benefit of all of that data that went into feeding and training that model. In other words, we have all of the vulnerabilities that already have successful or exploitations associated with them. We already have vulnerabilities that have successful exploitations in the wild. In fact, we're measuring the volume and velocity of those as well to tell you about whether or not we saw this a handful of times, or we're seeing this 10,000 times an hour or 100,000 times a day, or whatever the case may be. We also look at malware that's associated with them. We're looking at 0 days that potentially are within your environment using that CPE analysis. So there's a lot of different things that we can analyze about this vulnerability. in order to ultimately then apply that to the asset, look at the asset itself, understand whether or not the asset is exposed to the internet or whether it's in your somewhere buried deep in your network, but also understand the importance of that asset, what's running on that asset, to really give a risk score of the asset itself, to give you some sort of likelihood of what's going to happen, what is the risk of any given asset, and then of course you can group your assets together so you can start to really kind of measure out and say, well, this is what this product looks like in my organization, or this business unit, or this office, or this data center, or what my DMZ or what my Windows environment looks like. It doesn't really matter. You can kind of pick and choose and cut your groups any way you see fit, and we'll give you those risk scores, but then we'll also give you kind of a recommended punch list, what we call top fixes within Kenna, that's going to tell you, here's kind of a bang for your buck, or that efficiency list, right? If you're going to go out and do some things right now, here's the things that are going to reduce your risk the most with the least amount of effort. And then of course, we're going to tie that into ticketing and reporting and everything else. So with that said, you know, to summarize, what we did was ultimately build out several models, and then kind of, for lack of a better term, one model to rule them all in order to predict risk for the future. So not only are we able to measure what the risk is right now, but then we can get proactive about that to really tell you what's coming down the road so that you can get ahead of the attackers. Given the fact that you only have, in some cases, days or weeks to remediate a vulnerability once an exploit comes out, because we really start to see a lot of flurry of activity around there, it's really important that you have that buffer or that head start in your remediation efforts when it comes to risk. So with that said, I am now going to hand this off to Andy.
Hi there, everybody. I'm Andy Parks. I'm the Group IT Information Security Manager for the Enstar Group. I think as an organisation, probably we're fairly typical of most customers. The Enstar Group itself, the nature of the business is we survive by acquisition. So we're always acquiring, whether it be just data, it can be data and people, or sometimes it could be systems. And quite often when we acquire an organisation, yeah, guess what? Quite often their systems aren't in the best of shape. They are, yeah, they're riddled with vulnerabilities, as we've seen all the time. In terms of our vulnerability management strategy, as I said, we're very, very sort of stereotypical, or certainly have been. We will go out, particularly, we will scan all of our networks, our data centers, our endpoints, et cetera, across the board, across all of our vendors on a weekly basis, and pick up all the vulnerabilities. We have a patching schedule as a patching standard, whereby, particularly concentrating on Microsoft patching, we will patch, so again, basically on a monthly and weekly cycle, with an option there to expedite anything that we deem as being critical. Now, at the end of the day, when we do our vulnerability management scanning, again, our vulnerability management system is very good at finding vulnerabilities. Yeah, and at the end of the day, as Ed said, it'll kind of give you these big scary numbers in terms of the amount of critical and high risk vulnerabilities that we have across our estate, across all of the vendors. In terms of our patching strategy, yeah, we are, again, very, very stereotypical, and always have been, insofar as, again, we will look at the CVSS score, we will look at that and look to remediate on the basis of an SLA all of the critical and high vulnerabilities that we've got throughout our estate. Now, obviously, doing that is, like I said, is extremely time consuming, extremely inefficient, and let's be honest here, we do quite often we miss that SLA because it's just too much work. There's so many vulnerabilities out there. There are so many moving parts. It's impossible to manage all of these critical and high vulnerabilities just based on the CVS score. So what we really look to do is what Kenna has enabled us to do is basically take a more intelligent approach. So what is it we really need to fix? What do we need to worry about? what vulnerabilities out there are actually have been exploited out there in the wild, that we actually, again, that we need to concentrate on and remediate those vulnerabilities, as opposed to everything across the board. What that's done is really just allow us to really develop our vulnerability management strategy, and to take a risk-based approach, as opposed to something that's just purely based on a CVS score. Also, as well, when you look at vulnerability management solutions, what they're good at doing is they're very, very good at identifying vulnerabilities. What they're bad at doing is reporting on those vulnerabilities as well. So I think, as we all know, if you try and talk to senior management within the business, or even senior people within IT, quite often, as soon as you start talking technical, they will switch off immediately. What business people and what senior people within IT understand is risk. And if you can, and similar to anything within information security, if you can quantify something in terms of its risk, then business people will understand that. So what we're doing with Kenna at the moment is actually presenting basically the vulnerability management as a risk score now, instead of presenting people with huge, great, big, scary numbers in spreadsheets saying we need to fix all of these, and people will look at you blankly and think, well, what does this mean? You're never going to get anywhere. You'll basically, you might sort of attack the tip of the iceberg, but that's it. The rest of it you will never get remediated. So what this has done is allow us to take that, again, that risk-based approach, and allow us to senior management to now understand where we're at with vulnerability management. Because previously we were getting asked questions and we were pulling reports out of our vulnerability management solution, but really didn't shed any light on what the problems were. And senior management, board members would just switch off immediately. Now what we're doing with Kenna is the fact, like I said, we can give it that risk-based score, and they now understand again where we're at with vulnerability management. We can then drill down. So what Kenna allows us to do is not just have an overall risk score, which we can then over time show continuous improvement as we improve that risk score going forward quarter by quarter. We can then also drill down on certain technologies. So we can give obviously different risk scores for different operating systems that we've got throughout the estate, different software, different technologies, different vendors, and we can see where we can drill down and see exactly where our weak points are. And one of the beauty of of Kenna is it not only gives you those recommendations about where your top fixes are, it'll also tell you if I remediate X, Y, and Z, I will reduce my risk score by, say, from 500 to 400, just by remediating, say, 3 critical vulnerabilities that I've got throughout my estate. So that is probably it in a nutshell, I would say. Like I said, it's allowed us to actually be more intelligent and certainly more efficient across the board in terms of vulnerability management, and been able to kind of ditch that traditional approach, which just wasn't working anymore.
That's brilliant. Thank you, Andy. Okay, so I think we're going to now open it up to questions. So if you do have any questions, there is a questions box just at the right-hand side of your screen in the control panel. If you just write them in there, I'll get them read out for Ed and Andy. In the meantime, see if any come through. I mean, could you maybe elaborate the next steps for NSTAR?
Yeah, I think so. I mean, I think as I've just kind of already alluded to, I think, like I said, it's what it's done is it's allowed us to develop and completely change, in fact, our approach to vulnerability management. So I'm in the process at the moment of updating our vulnerability management standard, which at the moment, as Ed said, very, very traditional. It's all based on the CVS score. It's all based around SLAs. We can now change that completely, turn it on its head, and now take a risk-based approach around how we manage vulnerabilities. We'll still do sort of rolling patching in terms of Microsoft security fixes, for instance. Though that will still go on there, but what we can do now is be more targeted, be more intelligent about the way, again, in what we remediate. Particularly around things like endpoints, for instance, applications such as Office, and all the usual suspects, such as browser components like Java and Flash, I mean, those probably for us, those are the major pain points.
Thank you, Andy. Okay, so it appears, I don't think we have any questions, which is great. You obviously all covered everything off in the webinar, thank you. So as mentioned previously, we will be sharing the recording with you all this afternoon, and there is a really short feedback form at the end, so if you would like any more information, just pop that in there and we will get back to you. Okay, so thank you, Ed and Andy, for presenting on the webinar today, and thank you everyone for joining. I hope you enjoy the rest of your day. Thank you.
Thanks, bye-bye.
Thank you very much.